lesson 9.5. We're talking about loans. And the formula that they give you is the amount of loan that you have is equal to the payment times 1 minus 1 plus R over N. It's a periodic rate raised to the negative NT power. And that's going to be divided by the periodic rate, which is R over N. So let's say that you have your eye on this beautiful car. And the car is priced at $50,000. So that's the amount you're going to need for your loan. That would be L. And you want to know what the payment would be if you could finance $50,000 for 7 years. The interest is compounded monthly. And you have an 8% interest rate. So to calculate your payment, we're going to borrow $50,000. Our rate of interest is 8% compounded monthly. And we're going to use the money for 7 years. Be careful in your calculations. Remember, I do what's in the brackets, but I do what's in the parentheses. So I have to divide .08 divided by 12. So I can put that in the denominator. And I can go ahead and add 1 onto that for the numerator. Now, 12 times 7 is 84, so that's raised to the negative 84 power. Now, a negative power doesn't make the problem negative. It makes this a fraction. That's what it does. So the payment is to be put back in, and so is the $50,000. Alright, now with your calculator you can type this in as you see it if you're careful. So I'm going to type in 1 minus, and then in parentheses I'll put 1.00667, close my parentheses, raised to the negative 84 power. So I have 1 minus parentheses, and then this number, close the parentheses, raised to the negative 84 power. I'm going to press enter, and then I'm going to divide that by .0066667, and press enter. And so that gives me 50,000 is equal to the payment times 64.1799. So I'll take $50,000 and I'll divide it by 64.1799. And my payment would be $779.06. So for 7 years, I would have this payment for my car. Now, if you are looking for the amount of time, remember that you're going to be having to use the natural log. So if you know the loan, you know the payment, and you know the rate, and the number of times it's compounded, and you're wanting to know how long it's going to take you to pay off that loan at that rate, then you're going to have to use the natural log. So let's look at a problem like that where, let's say that I want to borrow some money. Say I want to borrow $20,000. So that's going to be my loan amount. And on my income, I can only afford to pay $250 a month. So that's going to be my payment. And I want to know how long that's going to take me to pay that back at an interest rate of 8% compounded monthly. So I go to my formula. The amount of the loan is the payment times 1 minus 1 plus r over n raised to the negative nt power over r over n. Wow. So I'm borrowing $20,000. I can make a $250 a month payment. I'm paying 8% interest compounded monthly, raised to the negative 12 times t. I don't know what time is. That's what I'm looking for. And I'm dividing that by 0.8 divided by 12. So I have $20,000. I'm going to go ahead and divide 250 on both sides of the equation so I can get rid of that. So that gives me 80. Now over here, I'm going to take 1 plus 0.08 divided by 12. And that's raised to the negative 12t power. Now I cannot subtract 1 minus this number because this number is all raised to that power, and that can't be combined. And I'm dividing that by 0.006667. But what I can do is get rid of this denominator by multiplying both sides by 0.00667. And that gets rid of the denominator. So 80 times 0.00667 we'll subtract 1 on both sides. And that gives me a negative 0.4664 is equal to a negative 1.00667 raised to the negative 12t power. Now I'm going to divide both sides by negative 1, and that makes them both positive again. Alright, now I'm ready to take the natural log, because I have this term isolated that has the power with the variable. So I'm going to take the ln of 0.4664 is equal to the ln of 1.00667 raised to the negative 12t power. Now this is going to come down in front. Negative 12t ln of 1.00667 is equal to the ln of 0.4664. I'm going to divide both sides by negative 12. ln of 1.00667 so everything goes out except the time. The ln of 0.4664 divided by negative 12 times the ln of 1.00667, and I get 9.6 rounded to the nearest tenth, so it would take about 9 years.